Welcome aboard. You're flying with Captain Taz, your trusted guide through CPL and ATPL theory, straight from the Oxford Standard. Clear, concise, and exam ready. Let's get airborne. So, hello everyone. In this journey, Captain Akshat and Captain Arya will be guiding you through the Oxford CPL and ATPL syllabus systematically. Our goal is to help you not only clear your exams with confidence, but also understand the concept with no sweat. Let's make learning efficient, enjoyable, and effective. We are starting with the general navigation, and the first chapter in general navigation is directions, latitude, and longitudes. Let's get started. Okay, so what is the shape of Earth? We have been told that the shape of Earth is spheroid, but in reality it is not. The shape of Earth is called as oblate spheroid. What does it mean? It means that Earth was a gas cloud, and due to the rotation, it was experiencing centrifugal force, which compressed its poles. How much? 0.3%. Remember this. The compression is 0.3%. It means that the Earth polar diameter is less than equatorial diameter. How much? 23 nautical miles or 27 statute miles or 43 kilometers. Correct? Easy? Next, we all know is what are directions. We know the basic direction: north, south, east, west. Okay, these things will be very useful for you. If you know your position, like in every concept, you will be needing your directions. So yeah, I think you already know what are directions: north, west, east, south. These are the directions. These are the quadrant. This is called as first quadrant, second quadrant, third quadrant, fourth quadrant. We'll get more into it later. Next thing is, if you are on the North Pole, you will see that Earth is rotating in anti-clockwise direction. And when you are in South Pole, clockwise. If you are on the South Pole and if you watch Earth rotate, it will appear like it is rotating in clockwise direction. But when you are on North Pole and if you see Earth rotating, you will see that the Earth is rotating in anti-clockwise direction. Correct. Next comes the basic hypothetical points on Earth. Okay, we all know what is North Pole. Most northern point on Earth is called North Pole. Most southern point on Earth is called as South Pole. And it differs also. It could be geographical or magnetic, which we'll study later. Okay. So what are poles? Poles are the extremities of the Earth. Extremities of the Earth axis is called as poles. Correct. Then comes circles on the Earth. What are different circles on the Earth? The first thing you need to understand is great circle. What are great circles? Great circles are circles on the surface of the Earth which has same center and radius as Earth itself. What does it mean? It means that the great circles are the circles whose center is same as Earth and whose radius or diameter is same as Earth. Examples of great circles are longitudes and equator. These have same center as Earth and same radius as Earth itself. Okay. And if you have given a situation in which 2 points you have given which is not diametric opposite, it means that it is not diametrically opposite like this. It is more like this. So how many great circles can you draw or can be formed? The answer will be 1. But if the situation is you have diametrically opposite points, then it can be infinite number of great circles. Next come equator. I think we all know what is equator. As I already mentioned, equator is a great circle whose plane is at 90 degree to the axis of rotation of the earth. 90 degree. And equator is also a point on the surface of the earth which divide the earth into two hemispheres, northern hemisphere and southern hemisphere. Equator is also called as 0 degree latitude. Correct. Let's go ahead then. Next are meridians. Okay, what are meridians? Meridians are semi-great circle. It means what are great circles have same center and radius as Earth itself. Meridians are semi-great circle, means half part of great circle. Half part of great circle is called as meridian. If this is my whole latitude, the only this part, or correction, this is my whole circle. If only this part, half part, this will be called as meridians. Okay, and there is a meridian which passes through Greenwich. It is in Europe, and that meridian is called as Greenwich meridian. It is also the datum. Greenwich meridian is datum. All the longitudes are calculated from Greenwich meridian. Next come small circle. Small circle are the circles on the surface of the earth who doesn't have a same center and radius as earth itself. So it is opposite of great circle. So all the circles on the earth except longitude and equator are small circles. Example, Tropic of Capricorn, Tropic of Cancer. These all are small circles. All the parallels of latitude are small circle except equator. Correct. Next is graticule. Graticule is nothing but the combination of latitudes and longitudes. These are called as graticule. Simple. If you have any doubt, you can comment it down. I can try to explain it better. Now let's come to the topic latitudes. So according to the latitude and according to the Oxford, latitudes have a definition in which it explains that it is the point measured from the center of the earth along the meridian. These are the meridian. These are the point. Okay. We all know the basic definition of latitude. The important concept to note is the difference between geodetic and geocentric latitudes. There are two types of latitudes. geodetic and geocentric. On the charts that are there, we use geodetic latitudes. I will explain both the concept right now, okay? So the latitude which is drawn from the center of the earth along a meridian is called as geocentric latitude. In this example, you can see the red part. The red line is drawn from the center of the earth along a meridian. This angle is geocentric latitude. Now comes geodetic latitude. Geodetic latitude, okay. So if you draw a line, correction, if you draw a point along a meridian, and if you draw a tangent to that point, and then draw a parallel that is 90 degree to that tangent, the latitude which you will get is called as geodetic latitude. I know it must be confusing, but think it like you have a point along a meridian, you draw a tangent to that, and you just draw a straight line from the tangent. The latitude you are getting is called as geodetic latitude, and these are widely used. Geocentric latitudes are also there, but they are not that widely used or widely popular. Geocentric is very simple. Just draw a point, just draw a latitude from the center of the earth. That is geocentric. And if you draw a tangent, then it is called as geodetic. Correct? Thing to remember is that the maximum difference between GD, geodetic, and geocentric is 11.6 minutes. You know minutes? Okay, let me tell you. 1 degree equals to 60 minutes, and 1 minute equals to 60 seconds. If you are not about this thing, let me know, but I think I have explained it. So 1 degree have 60 minutes and 1 minute have 60 seconds. So maximum difference is 11.6 minutes, okay, which happens at 45 degree north south. Correct? Remember this. Maximum difference between GD and GC is 11.6 minutes, which happen at 45 degree north south latitudes. Correct? Now comes longitude. Longitude, I have already mentioned a little bit about it. Longitudes are measured from Greenwich. Okay, let me explain. If this is my Earth, I am hypothetically taking this as my Greenwich meridian, which is 0 degree longitude. My longitudes are measured from this only, 0 degree. So according to Oxford, the definition is that longitudes are measured along the equator from Greenwich meridian. This is my equator. So if this will be my longitude. Pretty easy. Next, which is very important topic, is that finding the difference in longitude between 2 points. If I have given an example that my initial position of a aircraft is 45 degree, 45 degree west, final is 45 degree east. What is my difference in longitude? So before getting into the solution, I want you all to take a piece of paper and make a table like this, which is shown, and I wanted to cut it out and joint 180 to 180, 180 east to 180 west in a circular pattern, and try to solve these questions. Then in this question we have given that the initial position was 45 west. As we already know, right side is east, left side is west. This is north, this is south. Correct. To find the difference in longitude, it is given that 45 degree west. So they are telling me that my position is this, initial position, and then my final position is this. What is my d long? Simple, by looking at the table, looking at this, you can calculate 45 plus 45, that is 90 degree. Difference in longitude is 90 degree. Correct. If they have given me the question like my initial position is 90 degree, I have traveled 90 degree west, okay, and I have traveled 90 degree east. What is my final position? So in this, they have given me d long. They have given me that I have traveled 90 degree in easterly direction. So I am here. I have to travel east. Right side is east. So if I am traveling 90 degree to easterly, here, what is my final position? 0 degree. 0 degree east west. And one thing I also would like to add is that for writing latitudes, the method is like this. Correct. And for writing longitudes, you have pattern like this. That extra 0 after a minute can be eliminated, but for the first two part in writing latitudes, it will be 2 digit, because we all know the maximum, the north pole is 90 degree, whereas in longitudes the maximum is 180 degrees, so 3 digits. That's it. I think in the next chapter we are going through this topic one more time. So if you get this concept 50% also, then you are okay. Now we will do Oxford backward questions. Okay, I want you all to open the books for this. So for first question, it is given that what is the approximate compression of the earth. I have already mentioned it in the module, it is 0.3%. Graticule is the name given to question second. Already mentioned, a series of latitude and longitude lines drawn on a chart or map. We can skip the third or fourth question because they don't ask these type of questions in your examination, because the concept is not that necessary. The question fifth says that the given the compression value of the earth is 1 divided by 297. And at the semi-major axis of the earth measured at the axis of the equator. So semi-major axis of the equator is 6378.4. What is the semi-major axis of the earth measured at the axis of the pole? We have given earth diameter We have to find polar diameter. We have already given the compression, that is 0.3%, that is 1 divided by 297. So I want you all to open your scientific calculator and just six three seven eight decimal 4 into 1 upon 297. What you will get? 6378 decimal 4 divided by 297. The answer you are getting is 21 degree 28 minutes. Just subtract this answer from this. We know that polar diameter is less than equatorial diameter. So if we subtract 21 degree 28 minutes from 6378 decimal 4, the answer we get is 6356 decimal 9. That is your answer. So summing up the module, we studied about the shape of the earth, the compression ratio, it was 0.3%. Earth polar diameter is less than 23 nautical miles, 40 or 43 kilometers. Then we studied about the basic direction, north, south, east, west. We studied about the perception of rotation of the earth from north pole or south pole, which was anti-clockwise in the northern north pole and clockwise from south pole. Then we studied about the different circles on the surface of the earth, which was great circle, semi correction, small circle, great circles, meridians, equator, etc. Then we studied about latitude and longitudes, different types of latitudes, that was geodetic and geocentric. What are longitudes? What are the difference in longitude and how to calculate it? We'll go into this topic from the next chapter itself. We did few questions from the back, and that's it. Thank you. Please give your feedback. How can we make this better for you to understand? Thank you.